Good afternoon. I'm Ted Cochran. I'm going to be talking about rocket safety on the range today. Welcome to this talk. You may have heard a talk earlier by Todd Smith on risk management that described kind of the theory of how folks go about assessing the risk and mitigating the issues that may occur in flying. I will argue that the National Fire Protection Association and the National Association of Rocketry, through their codes, have done a pretty good job of, in general, doing that analysis for us. So I'm not going to go into the theory so much as a lot of practical experience that have been gained over tens of thousands of flights. I've been associated with the National Association of Rocketry for 20 years or so, and in various capacities as trustee, vice president, and president. I've heard a lot and seen a lot of interesting flights, and I'm going to try to talk about how we're going to manage the risks that's associated with them. So I'm going to assume that your rocket is ready to fly. You've simulated it, you've ground tested it, you've prepped it with a thorough checklist, the RSO has been over it. So now we're going to talk about what happens next. So we're going to talk about before the flight, at the pad, during the flight, and during recovery. Before the flight, a lot of people go to, especially if you're going to a national event or to an unfamiliar range, or you're just starting up a range, you have to be familiar with the general hazards of rocketry, the area-specific hazards. So here I'm talking more about the climate that you're in and the kind of terrain that you're in, and then the location-specific hazards. What is there around your specific launch site that may present a risk that you have to mitigate? Also, before the flight, you should become familiar with the emergency procedures at the site, or create emergency procedures for the site if you're the one in charge. You should personally know how to call for help. There's no guarantee that you will discover something near somebody who does know how to call to help. So you should know, how do you get in touch with the fire department? How do you get in touch with emergency medical services? It also helps us if you know how to help fight a fire and when not to. And also if you know how to do basic first aid and help with a medical emergency. So the general hazards in rocketry are pretty well known. There's an injury risk from being struck. There's a property damage risk that includes fire and the impact of rockets. I've got an example up here in the right corner. I think you can see this arrow. This is a Comanche 3 that didn't stage. That's not uncommon. And just to show you what kind of power those have when they come in ballistic, it went through a poor little rocket that was waiting on a prep table, and then it went through the table itself. So that's the point sticking out. So even little model rockets can have a significant injury risk from being struck. Let me go back over here. So the fire risk is one of the biggest risks that we have in terms of monetary loss. It's the biggest risk to launch sites. I know many launch sites have been lost because of fires or the threat of fires. The picture there you see is from a NARAM that occurred in Ohio, and I'll talk more about that in a minute. So many of the causes are people not actually following the safety code. The pad area has to be cleared of combustible material. Down at the bottom, I have the two safety codes and how much clearing needs to be done. And in particular, high power rockets require all combustible material to be removed in the area of the pad. And there's different sizes of those areas depending on how big the motor is. Blast deflectors also need to be adequate. And sparky motors we need to be particularly careful with. And I'll show you some slides in a minute about that. Also, make sure you're prepared. Again, have a response plan, have suppression equipment, and make sure there's water in it. Water is the best defense against brush fires. A 10A fire extinguisher is good for little teeny things, but really water is what you need. And if the fire is anything other than trivial, call for help, because most fire departments are much happier coming out when the fire has already been put out by the time they get there than they are having to spend 5 or 6 hours in the field fighting something that gets away from you. And also, don't fly in red flag conditions. we all like to fly rockets, but it's really a bad idea to fly when the weather is bad for you. So let's talk about the causes of general hazards. There's failure to follow the safety code, which is pretty comprehensive. Failure to prepare for uncommon but not unpredictable incidents. And these include unexpected trajectories, rocket malfunction, ejection or motor ignition near people, no deployment, main at apogee, launch system malfunctions, and human error. So again, the various codes that we have in effect are pretty good at covering the hazards that can occur from these kinds of things. What we have to worry about are the kind of Swiss cheese model of incidents where a bunch of little holes in the processes line up, and as a result, something bad happens. So unexpected trajectories. This can occur because of unexpected instability or a shred, you lose a fin, or a malfunction. You can get rod whip or the instability of the pad or rail. You can have weathercocking. You can have the launch leads get snagged on the rocket, or the launch device itself gets snagged on the rocket. So here's some examples. This happens enough that we should figure out how to guard against it. The severe rod whip can occur especially with larger diameter rockets on skinnier rods. Most clubs are correctly going to rails, and I think that can be encouraged. There's a middle picture there of what happens if you have a rail that's not fully connected to the pad. That's not a good flight there. Sparky motors, not only can they start fires, but if the nozzle gets partially obstructed by metal coming out, then the rockets tend to go unstable, or at least make a hard turn in one direction or another. And if you see enough pictures or enough flights of Sparky motor flights, that sign of black smoke out of one side and all the sparks and flame coming out the other is a pretty good indication that the rocket's going to be turning. Also, some rockets are just hard to simulate, and they're also hard to swing test, and it's not completely simulations account for them, so we have to be especially careful with those. So here's some common malfunctions we ought to worry about. We should worry about far-flung burning propellant grains in the case of a CATO, or a rocket that crashes off-site, which is roughly the same kind of hazard. The Sparky motor plug nozzle. So this is the third picture I've shown you of this particular incident, and the reason I show it to you is when that rocket made a turn, it was a J-powered motor, and all of the sparks were thrown into brush that was further away than the NFPA requires, but still within range of those sparks. So you have to worry about that. And there's a couple examples of leads being snagged on the motor hook, and ejection failures, of course, are a risk. In the area-specific hazards, so those were the hazards, but in area-specific hazards, we're going to talk about heat, humidity, altitude, wildlife, plants that some people are extremely sensitive to, and the kind of clothing you need for the area you're flying in. So in Minnesota, we flew in fields that we needed snowblower or snowmobiles to recover the rockets, and it was 10 degrees or lower. That's one kind of personal risk for recovery, and the other kind is when you fly out in the desert and it's 110 degrees. So you have to be aware of what that may be and expect that you might be out in the field longer than you expect, and that you might encounter little critters like the ones I took. All three of these pictures at various NARMs around the country, and all of them would make for a bad day if you happen to encounter them when you were recovering. Location-specific hazards. So now we're getting into the actual launch site itself. Are there ponds, lakes, streams, trees, ravines, power lines, or other infrastructure nearby? Where are the houses? Where are the unfriendly private property owners? Where is the livestock? Where are the crops? So all of these things are worth being aware of as you go out to fly. The recovery hazards in particular, if you fly off range, and you're not supposed to, as we'll talk in a minute, there are some hazards that are worse than others, right? So if you fly into a neighboring field and the farmer is not too unhappy with you going there, then that's one thing. But if you land in a power line or a lake or a ravine or a tree, that's worse for you. And some hazards are worse for people not associated with the launch, and those are the ones we are particularly needing to avoid. So power lines, you just have to avoid them. You must call the utility for removal if you happen to land in them. All but one of the fatalities that I know of that have occurred in rocketry on the range have occurred with people trying to remove rockets from power lines. If you just leave them there and don't call the power company, that's maybe considered in your state an attractive nuisance, and that can lead to significant liability if somebody else tries to get them down. Utilities can charge for removal. They usually don't, but they can, and so it's just better to avoid the things altogether. We've had very nice fields lost because rockets keep landing in their power lines nearby. Also, try to avoid landing off the range. Again, it's not you're not flying according to the safety code if you do that. We all know that it happens, but you have to be careful that your rockets aren't landing in a hazardous location. You're not having people get lost or injured going out looking for the rockets. We had an incident last year with disturbed livestock that led to a loss. We've had incidents in the past where farm equipment has been damaged harvesting a field that had a lost rocket that had been left in it. So the header auger alone on a corn picker was $6,162. Just add to cart. That's what that cost. And we paid even more than that for a corn head, I think, in NAR. So you're not supposed to fly your rockets under conditions where it is likely to recover outside the launch site. That's in the safety code. So what you want to do is make sure that bad things happen in safe places. We know that bad things happen. It's part of part of what we risk every time you push the button. That's my Saturn V out there, so I know well that it can happen. But you really want to make sure it happens away from flyers, spectators, parking, within a predicted area on your range and with a pre-planned response. So how do we do this? And in particular, how do we make sure we stay on the range and in safe areas on the range? The biggest manage the trajectory of the rocket. So even if the range is near hazards, you can avoid them with careful trajectory management. So in order to do that, you have to worry about both what happens if the nose cone doesn't come off and you have a completely ballistic flight, or what happens if you have drift with the parachute coming out during descent. You need to consider altitude, hazard distance, wind speed and direction, and weathercocking effects, all of those things at once. You can use dual deployment. That helps a lot, as you'll see in a minute. But if you have main and apogee, you have to worry about in which directions the wind would blow you into an area you really don't want to land on when you have a main and apogee. And then we'll talk about using rail tilt to advantage. So down below, I have a little table. This presentation will be online on our website for you all to grab if you want to look at this table in more detail. But it's just a brief analysis of if the wind speed is 5, 10, or 15, or 20 miles an hour, top to bottom, and your apogee is between 500 and 5,000 feet. This is how far you can expect the rocket to drift. So even a 10-mile-an-hour wind, if you're trying to go to 3,000 feet, you can walk half a mile easily. And some of these distances, anything in red is over close to a mile. So not too many fields that I know of have recovery range of a mile. Be aware. So here's an example, and this is the kind of thing that you can do with your own site or when you go see a new site. So this is a 4,000 by 2,000 foot flying field, and we're going to use it up to K motors. Various typical recovery hazards are around lakes and woods and houses and a road and an electrical substation and a power line. It has a 4,000 feet AGL limit because the limit can only be twice the smallest dimension, and the smallest dimension on this field is 2,000 feet. And the safety code limits your pad placement to areas that are 1,500 feet or more away from houses and roads, and also away from the boundary of the launch site. So this using for how you can do trajectory management to keep your rocket on the range, and certainly worry about the critical hazards in this picture. So if you put the pad in the center of the range, the rocket drift is limited, right? You can't go more, if the apogee is right over the pad and the rocket drifts over 1,000 feet, you're off the range. So even a nominal flight over 500 feet in altitude can drift off the range. So that's not a great situation. So what can we do to avoid that happening? One thing is be aware of the wind, obviously. So if the wind is from the north or south in this particular example, your rocket will go off the range if you are flying in anything other than these little green boxes over here. So 5 miles an hour or less, you're good to 2,500 feet if you fly straight up. But in 10 miles an hour winds, you can only go to 1,000 feet if you're lucky. So you have to pay attention to which way the wind is blowing to stay on the range. If you use dual deployment, like most of us do these days, you're in much better shape if the dual deployment works. So in this particular example, you can go to 4,000 feet, even in 10 mile an hour winds, if you use dual deployment and you eject straight over the top of the pads. Obviously, you can go higher if the wind happens to be from the west, which in most of the U.S., northwest, or west winds are more common than east, but you still got to pay attention to the wind. You can also move the pad, and a lot of clubs don't do this maybe as much as they could because, you know, parking is at one side of the field and nobody wants to walk to the whole length of the field to get to the pads or the prep area in front of the pads. But keep in mind that you gain a lot of altitude possibilities and recovery area when you do that. So again, here's the wind. We've moved the prep area to be crosswind, as NAR recommends. And now you can pretty much fly to 4,000 feet without any trouble. I note that the 4,500 and 5,000 feet is always red on this field because you're not allowed to fly higher than twice the length of the smallest dimension of the field. Another thing you can do is be wary of weathercocking. So if the wind is, again, in this example, is blowing north to south, if you've moved your pad so you can get more drift recovery area, you might have a rocket that weathercocks and ejects off the range, which I'll show you in a minute why that's really bad. And you're really not supposed to do that either. So you have to worry about that. You've moved the pad. What else can you do? You can tilt the rail. If you tilt the rail, I'll show you in a minute in which directions to do that. But if you tilt the rail, you can keep the ejection right over the pad. And the way to do that is tilt it away from the wind. If you tilt it into the wind, a lot of people like to do that because then the rocket drifts back within the recovery area. But you run the risk of having the rocket fly horizontally if it gets too much into the wind and go way up range. And then if the parachute doesn't land, not just off range, but it lands ballistically off range. So down at the bottom right, I have some examples of the kinds of trajectories, parabolic trajectories you might get if you have a no deploy situation and you have a tilted rod. So tilt away from the wind to reduce the weathercocking, but every rocket is different. And if you have a big rocket that you're particularly proud of, you might want to simulate that rocket in different wind speeds and different directions on the particular field that you're at, and then figure out where the rod should be tilted to give you the best chance of recovery and the least chance of a downrange or uprange ballistic return. And worry especially about that for rockets that you care most about, but also for rockets that are a bigger hazard to civilians. So I know that I showed you an example of what a Comanche can do to a table, but 20-pound Tethys can do a lot more damage than that. So you really have to be more careful with those rockets, and they deserve more of your time in simulating them. Okay, so we're doing everything we can to stay on the range, and yet we know things happen. So here's some advice for how to worry particularly hard about the more critical recovery areas outside your range. So sometimes landing off range isn't such a big deal, as I mentioned. You land in a bean field, okay, if the farmer's not unhappy. It's not great, but at least you can walk out and get your rocket. If you land on a house, that's a much worse thing. So you need to be aware around your range and on your range where the most critical issues are. Those are the critical hazards, and you need to have extra precautions for those hazards. So here's the first hazard, main at apogee. This happens a lot, especially when folks are first learning how to do main at apogee, or sorry, how to do dual deployment. There's a lot of little nuances about doing that, and it may take 10 flights to be really good at it. So in the meantime, you need to be aware of where would your rocket go if the main came out at apogee, and what would the consequences be. So if you land in a substation or on a power line because your rocket, your parachute came out at apogee, that's a really bad outcome. And the way to avoid that is to pay much more attention than you normally would to the wind, the angle, the location of the pad, and those things. So you make a go, no go decision based on that. If you have any risk at all of landing in the substation, that's not the day to learn dual deployment. And along with that, there's another example of no ejection. This doesn't happen as often as main at apogee, but it's a much worse risk when it does happen. So here's a rocket that was flowing, and they wanted the ejection to be here over the range, but because there was no parachute at apogee, the rocket followed a ballistic trajectory and landed in a really bad place. So in this particular case, you would want to be especially careful when the wind is from the west and you're going over an altitude that would lead to a ballistic deployment off range. So a lot of folks have done these kinds of analyses in a proactive way. Here's an example from the NASA Houston Rocket Club. They fly on NASA Johnson's site. So it's a government site. It's a nice, large site. It's in Houston, so there's lots of suburbs around. And they have houses in places that they really don't want to land on. So they have a little table that they've incorporating wind gusts and higher winds at altitude and the direction of the hazard and how high the flight is going and the wind speed and direction. And they've made these pie charts. So if you're flying, for example, below 1,000 feet, then it doesn't matter. You can fly whatever you want there. There's no way it's going to hit something critical. If you're flying to as much as 2,000 feet and your descent rate, let me get over here. Hang on a sec. I'll move my arrow. There we go. Then you don't. If the wind direction is from this direction, you cannot fly that day to that altitude because there's a chance that you'll go somewhere where the rocket is not welcome, or you could have an incident. So you can see for each of these possible altitudes and descent rates, they have identified the direction of the wind that they will allow those flights to occur to these different altitudes. And you can do that for your own rockets ahead of time, especially if it's a rocket you care about or a rocket that represents a particular hazard that you want to avoid. Okay, so you've done all your homework. You know your field, you know the area, you're going to Narrum doing sport flying, but you've looked at that area and you know kind of what's around and what to avoid, and you have your water. You're ready to fly, and you're going to maximize your safety and the safety of others at the pad during the flight and during retrieval. So here's an example. This pad wasn't quite sturdy enough that I wanted to fly it on, so went to Walmart $14 worth of sand, and that was rock steady. That flew out very well. And it's there for the next flyer. So during the flight, sorry, skipped one. At the pad, this is really important. So a lot of people may not, and this is, I happened to be launching with TARC teams this morning, and I saw a lot of this going on. People just want to throw the rocket on the pad and hook up the clips and go get it launched, and chafe at the delays while other people are being launched. But you really have to be a little more meticulous than that. So ahead of time, you should have a list of what you need at the pad, including things like extra igniters and the tools that you need, and a ladder if you have to arm your rocket from any kind of height. You see people sometimes climbing up the side of a tower to arm a rocket, and that doesn't, that's a fall hazard as well as a rocket hazard. You want to confirm that the pad area is clear, anything that's combustible up to the safety code limits and maybe beyond. You get to excuse anybody who doesn't need to be there, especially high power we're talking about here. Confirm the pad is stable and capable of handling the rocket. Add the weight to the legs or stake them if necessary. Confirm that all the pad bolts and fittings are tight, so you're not carrying your rod with you as you go. Confirm the wind speed and direction are acceptable. So if this is a flight that you're concerned about, high altitude or whatever, this would be the time to confirm, to know ahead of time what your limits are. The winds have to be below a certain amount from a certain direction, so that you're going to have a successful flight and a not dangerous flight if it isn't successful. Confirm that the leads are cold. There have been more than one case, including one that I did, where not doing that led to a launch right next to the person who was trying to hook up the rocket. So that's never good. Load the rocket, tilt the rod at the pre-planned angle. Again, you know what angle you want to tilt it to given the wind direction. Arm the electronics, then insert the igniter and connect it. We arm the electronics first in case something unusual happens when the igniter is inserted. If the rocket were to launch unexpectedly, at least it would have a parachute when it came back out. You wouldn't be having two mishaps on the same launch. Ensure the leads are not shorted, they won't snag, and they won't fly into dry grass. At student launch last year, we had cases where there was lots of clear area, but the leads would go flying. Some of these motors were kicking the leads way out into dry grass, and that had to be mitigated pretty quickly. And then if you scrub for any reason, safety electronics before you move the rocket. And don't rush and don't ignore issues. Sometimes you might be the last person at the pad and you get some little thing that has to get fixed, and you're tempted either to leave it or to launch without fixing it, or less politely, but you stay there while you're the last one and everybody on the whole range is waiting for you. If something like that happens, just step back until they launch that rack and go back and fix it the next time. Don't let the rocket go off if you're not completely ready to launch. Oop, went the wrong way. So during the flight, watch the rocket all the way up and down. Don't be distracted. I lost a rocket because somebody called a heads-up flight while my rocket was still in the air, and I looked for the heads-up flight and then never saw the rocket again. So that's too bad. Make a note of anything that happened unexpectedly, any parts falling, things like that. Both it might be falling, but also to fix whatever happened for the next flight, stability issues or spinning that you don't like or whatever. Make a note of where it lands, and in particular, if it landed kind of far away, get an object on the horizon to use as a landmark, and then you can do something like use a compass bearing if you remember the use of magnetic compasses, or a mapping app like Strava on your phone to establish a line of the rocket that you can then walk. And then if the rocket is off the range and it's a range you're not familiar with, ask the local section members for advice if there's anything out there that you should be aware of. Before leaving the range head, let somebody know where you're going. Take water, phone, binoculars, tools, everything you need to be out there for a while looking for your rocket, especially if you know it's going to be a hunt, right? If you're in a field or you're in woods. Before going on private property, make sure you have explicit permission. Either the club has gotten it from neighboring landowners, or you go up to their front door and knock on their door and ask them if you can go look for their rocket. Leave the gates as you found them. If you go through a gate that's open, leave it open. If you open the gate to go through it, close it again. They're in that orientation for livestock management purposes, if nothing else. And if you do not find the rocket, report the approximate location to the landowner. This will help them avoid ingesting it into a combine and causing $10,000 worth of damage. Trees. Don't climb trees. Use long poles or ropes. They're rope throwers. That big shot line launcher actually works pretty well. There's one at Novar. It takes a minute or two to figure out how to do it well, but it works pretty well. Fishing rods I've seen used, bows and arrows I've seen used, as long as you're clear downrange of where you're shooting that stuff. There's two examples here. I don't know whether you can see the example on the far end, but there's a very long set of poles that have been taped together to get rockets down from pretty high. I think my personal record is 40 feet, but I know people have done better than that. But don't recover it from a dangerous place, with a pole or otherwise. Tall crops. So this is a hazard for the folks who will run over your rocket more than it is, and it's a hazard for you losing the rocket. It's not really an accident hazard necessarily, but if you have that bearing and somebody is at the range head, you can use a long pole with a walkie or a cell phone if the service is reliable, and then you can kind of walk through the corn with that flag over your head and have them direct you in. Usually I have found that the rockets are further downrange than I think they should be. So if you're in doubt, keep walking further out, not come back in. If you use an RF tracker, that will really help, assuming that it works, and maybe an audible tracker as a backup. And something that I have found very helpful in my own flying is a really long length of surveyor tape. It's thin plastic, so you take it out of the spool and make a ball out of it, or a tiny, and you just eject it with the parachute, and the wind will drive it across several rows of corn, so you can usually stumble across it without going through every 3 rows of corn like you would if you're trying to search for a rocket in high. Livestock. Did you know that cattle kill a lot of people? Both this particular headline was from the UK, but it's also true in the US. Avoid approaching livestock if you can, and especially avoid bulls and cows with new calves. They kill people. Get help from an experienced person. Leave the gates as you found them. Loose livestock can eat plants they shouldn't, especially like a new growing field. They can just stuff themselves and die because cows are stupid. Or they can get hit by cars and cause injury to an innocent bystander. And if we have to buy a cow, which has happened in the past, the typical value is $2,000 to $3,000, and horses, if you have to buy a horse, can be much more than that. So be very careful if livestock are involved in your rocket recovery activities. Private property. So there are people who don't like rocketeers, and some of those people live near rocket ranges, and it's their right to feel that way and to be protective of their own property. So treat that property as the kind of critical hazard I talked about earlier, and have wind charts and launch rod angles to avoid landing on that property. And if you do land on that property, you've lost the rocket. Just don't go there. Just don't ask. But if it's property you just don't know about, like your typical TARC team on a high school field that floats off into the subdivision and the rocket's in somebody's backyard, ask permission before entering property to retrieve the rocket. Almost everybody will be thrilled to help. And under no circumstances, go on roofs or use the property owner's ladders or other equipment or cause any damage without the owner's explicit consent. and reimburse them for any damages. To land on a metal roof and dent it, and they want to get a roof sheet to put on, then they deserve to be reimbursed for that. And if nothing else, give them a tip for their help. They'll be happy. Okay, crashed rocket. So now your rocket, for some reason, didn't go well and it crashed in the field. You should be aware that it may not be safe to handle. If the rocket, for example, came in ballistic, there's probably, or at least possibly, unfired ejection charges, and you've got mangled electronics. So you have to be very careful. And the safe arm disconnects that you think will help you they should, but they might not. They might be, the wires might be shorted inside. So remove the power to the electronics as safely as you can. Remove the batteries after you've done that in case there's loose wires flopping around in the debris. Collect any unburned propellant grains and all the debris. Again, it's litter. It can wreck mowers and farm equipment, and cows will eat it because cows are stupid. This also applies to found rockets. So different clubs, different sections have different policies about what to do with a found rocket. If you find a rocket in a corn, most clubs will say bring it out to the edge of the field. Some clubs will say bring them back to the range head. Some clubs say always leave found rockets alone, but maybe tell people where they were, or put them up, whatever. Find out what the rules are and follow those. So I want to conclude by saying rocketry is safe. All right, it's one of the safest things you can do outside. It's safer than Little League baseball. It's certainly safer than Little League football. But it's got this public presence, shall we say. It's very newsworthy if something happens. And as more people get involved and incidents do occur, the public's perception of safety might not match the empirical reality. So it's up to us to minimize incidents, especially those that could turn into accidents. So follow the safety code. It's got 60 years now of careful hazard analysis behind it, and develop your own personal SOPs for flying your own rockets, especially the ones that represent bigger hazards. Avoid the critical hazards in the area by planning carefully before your flights. Make plans ahead of time to be prepared if things do go poorly, and enjoy the flights that you do fly with confidence, and have a nice safe recovery right in front of the moon. So that concludes the presentation. Let me see what kinds of questions may have occurred in chat. How about, should the rocket be vertical before arming the electronics? Yes, unless there is some specific reason with the specific electronics not to, the rocket should be vertical, because it's still does not have an igniter in it. It's not going to launch. You might have something specific with this two-stage rocket, but that should be part of your planning for that flight. We have folks that use tilt switches or brake wires. I mean, those are not great methods, but if you're doing something like that, it's particularly important that you pay attention to how you arm the electronics for that rocket. If you tilt the rocket to take it down, with the electronics fire? Maybe, but if you disarm the rocket first, there's the switches on the side of your rocket, your method of disarming the rocket that the high power safety code requires, that won't happen. But if you do tilt it to take it down without disarming it, yes, the electronics might fire. What should we consider setting a found rockets policy? That's a really good question, and I think it probably depends on the range as much and the preferences of the club. So I've been in situations where there's 50 people in a cornfield looking for one rocket, and another rocket is found, and the person who found the rocket brings it back to the range head, and the person whose rocket it's still out in the cornfield looking for it for 3 more hours. So that's not good. On the other hand, there's situations when you find your rocket and bring it back to them because there's no way they ever would have found it because it was in some place they didn't expect. So I would think that that would be a nice topic for a section meeting to decide what to do, and maybe what the hazards are in the area that you're recovering the rocket from. I think if a rocket landed in the Big Icky and somebody was out in a rowboat, I'd sure want them to bring my rocket back rather than me going out there. Let's see, any other questions? Anything in chat? All right, thank you, Andrew. Okay, hearing no more, I'll let you go a few minutes early and enjoy the rest of your day. Thanks very much for attending.